Hi, I'm Paul. We're doing Leetcode must know interview questions. Today's question is simplify path. This is rated as medium, but I think it's kind of easy, really. I mean, it seemed more difficult when I first looked at it. I think the key insight here is don't try to do it. Reading the path a character at a time. It's easier to split the path on the slash character. So that makes it easy to do things like, you've got consecutive slashes, 2 slashes, 3 slashes, whatever. Consecutive slashes treated as a single slash. Okay, well, if we split on the slash, we're going to wind up with some empty array elements, but that's okay. We can just ignore them. Let's see. Well, let's read the challenge. You are given an absolute path for a Unix style file system which always begins with a slash. Your task is to transform. Transform this absolute path into its simplified canonical path. The rules of a Unix style file system are as follows. A single period represents the current directory. So let's talk about that. If we split on slashes and we get an array element with a single dot, we just ignore it. It means that it's the current directory. Okay? Double period represents the previous / parent directory. Okay, so we need something to represent a stack so that when we see a double period, we can just pop the stack, go back to the previous parent directory. Multiple consecutive slashes, we already talked about. Splitting on the slash is just going to result in empty array elements, which we ignore. And anything else should be valid, right? Valid directories or files, and we just push them on the stack. Path must start with a single slash. Directory separated by a single slash. Don't end with a slash unless it's the root directory. Don't have any single or double periods in the parent directory. All right, so some of these are kind of easy. Home is home. We just got to take off the final slash. Home foo. Well, we've got a double slash there. Just ignore one of them. This one, home, blah, 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 documents, and then the double dot. Well, that means pop the previous element. So we pop documents, we get home user pictures. This double dot, so I don't know, we're just going up to the root directory. We just got a single slash. This one here, what is going to happen is the instructions say anything more than 2 periods in a row is just considered a valid it's just considered a valid name. So push it on the stack, push the A on the stack. We get a double period here. Pop the A off the stack, push the B, push the C. Double period means pop the C and push the D and then ignore the single period. So we have canonical path slash 3 dots slash B slash D. That's it. All right, let's try and code this. I'm going to move this over a little bit, and this actually will move this down. All right, we're going to use we're going to use a deck, double-ended queue, but you can use it as a stack, and that's what we're going to do. So we'll say D E Q U. Whoops, UE, these will be strings. We'll call it stack, and that is going to be equal to a new array deck. Deck by itself is an interface, so we have to implement it actually as something. All right, split the input path. So we're going to have a string array. We'll call it directories equals path dot split. We're going to split it on slash. All right. Whoops, went too far there. Okay, we can use an enhanced for loop on that array and say for string dir for every directory in directories. There's only, I think, 4 possibilities here. So let's try this. If directory, if the directory is not equal to, let's say it another way. If the directory is just an empty string or it's a dot, then we don't need to do anything. The empty directory is just getting rid of extra slashes, and the dot means current directory. So we can say if the directory is not equal to an empty string and the directory is not equal to a dot. If it is, we're not going to do anything. Let me put a bracket there. If the directory is, well, there's a couple ways to write this, but if the directory equals a double period, then we're going to pop the stack. The double period means go up one directory. I'm going to write it like this. Actually, it's going to be kind of like this. I'm going to copy that and put it here. We'll say if the directory is not equal to a current dot, double dot, it's not equal to a double dot, then well, wait a second. Okay, yeah, we'll do this. We will push the directory on the stack. Okay. If it is equal to a double period, we're going to pop the stack, but only if it's not empty. So let's say if the stack is not empty, not stack is empty, we will do this, stack dot pull last. All right. So when we add to the directory, we're adding to the end. We're adding to the end of the deck. I mean, deck is a double-ended queue. You can add or remove things from either end. If you say stack add, you're adding it from the end, not at the beginning. It becomes the last element in the deck. So push is an add, pop is a pull last, which means remove the last element from the stack. All right, have we got enough things here to close a for loop? I think so. All right, so all that's going to do is set up the stack. Once we have the stack, we can use the stack to create a canonical path. So let's create a variable for it, final path. Here's one possibility we need to consider, and that is that, well, actually, let me look at this. You are given an absolute path. I mean, I guess it's possible. is there an example of this here? If we did that, I think example 4 here, the stack would be empty, wouldn't it? Let me move it over here. There's example 4. There's nothing to push on the stack there. And so the output is just a final, it's just a slash. It's a single slash. So let's consider that possibility. If the stack is empty, then final path. You know what? I wonder if, no, this is fine. This is fine. Plus equals the slash. All right, let's say there are things on the stack. Well, if there are things on the stack, then for string, I guess we can call them directories. For every directory on the stack, we're not overlapping that, right? Okay, good. For every directory on the stack, final path, plus equals, first time through, it's going to add the first slash. So the path will start with a slash, and then every directory will be separated by a single slash, and we'll say final path plus equals the directory. Okay? Once we have done that, we're done with the if. Okay, we are done with turning the stack into a path, and we can return final path. Okay, I'm going to run that and see what happens. Compile error, missing, okay, that is line 5, missing, parentheses, line 9 is missing a parentheses. What did I say there? So we had a missing parentheses, a missing semicolon. Let's run it again. All right, so that's accepted for basic cases. Go ahead and submit. Okay, 5 milliseconds. Memory use, it's not that great, but I mean, still, what did we do here that's using a lot of memory? Is it the double-ended queue? I don't know. Java data structures sometimes are memory heavy, but I mean, I don't think there's really any other way to do this other than split the input and then combine the directories with slashes. So that's it. I hope you enjoyed it. Please feel free to like, subscribe, comment, and see you next time.